Hello dear students, as you know already that we had already started with the chapter Gravitation of Science 1, in which already we have covered up the gravitational force and motion and then Kepler's law. Three Kepler's law already we had studied. Now we are going further part towards the Newton's universal law of gravitation. In this, the Newton's universal law of gravitation, we are going to learn about the law of gravitation given by Newton, in which he states that in the entire universe each and every object is having their own gravity and it attracts the other object, whether it is a smaller objects, the minute particles, or the atomic particles, or the moderate objects like you, me, table, chair, means every object around you, or uh, maybe it is larger objects like the earth, moon, sun, or the other planetary objects or the asteroids, meteors. Each and every object is having their own gravity and they attracts each other. Now the question comes, if they are attracting each other, then why the earth is revolving around the sun? The question and the explanation for it is nothing but given by the scientist Newton. In that, he explains about it with this a simple diagram where he indicates that there is a two object m1 and m2, and if they are having a masses m1 and m2 and they are apart by a distance d, means if they have this distance between themselves, then the relation between it can be explained by this formula, which states that the force by which two objects attract each other is nothing but directly proportional to the ratio of product of their masses, that is m1 into m2, and the square of their distance. You can see here there is a square of a distance, d square, and that gives a relation between the force of attraction between the two objects, which is located at anywhere in the universe. It all depends on their masses and the distance between them. Now, if I want to remove this proportionality sign, I have to place the constant, and that constant is nothing but a capital G, and this capital G is nothing but a constant of proportionality and is called the universal gravitational constant. This is called as a universal gravitational constant. Now, about this G, if we want to talk about further, as G is nothing but the constant value, and if you will see that the value of that is mentioned over here, that is a 6.673 into 10 raised to minus 11 Newton meter square per kg square. First of all, if I want to talk about this G plays a very vital role in finding out the gravitational acceleration due to gravity for the different planets, that we will see in a later part of the chapter. But here, the further part, when we see, they have given a one information over here, the force between the two objects also doubles when their mass, one of the mass or the one of the object's mass is doubled. And if the distance is doubled, the force decreases by a factor of 4. Why this comes? Because if you will see, there is a square of d in the denominator, means the d and f, if you will compare, you want to find out the ratio between them, then the they are inversely proportional, means as the value of d is increasing, the value of f will reduce or decrease, and the vice versa. If the d is in decreasing, then f will increase, means if the two objects are closer to each other, then they will attract with a higher force. Another information they have mentioned over here, the important factor they have given over here, important part they have given over here, the center of mass of an object is the point inside or outside the object at which the total mass of the object can be assumed to be concentrated. The center of mass of a spherical object having uniform density is at its geometrical center. The center of mass of any object having uniform density is at its centroid.